All right, so we are starting the very last piece of information for the semester. This is our very last section for Unit 1, which is, our Unit 1 has been Chapter 7, but we're going to do one little section from Chapter 8 in here called arc length, and this will be all of our lessons for the semester. So our outcome is I can determine the arc length of a curve. So what is a rectifiable curve? Well, a rectifiable curve is one that has a finite arc length. So if we have a finite arc length, then that means we can actually find the length of the arc. All right, so the derivative has to be continuous, it has to be differentiable, the function does, and it has to be a smooth curve. So we're finding the length of a nice, smooth, differentiable curve using calculus. So it's just a formula, just a straight up formula. You can do this formula both in terms of x's or in terms of y's. So it doesn't matter which form that the equation is given to you in, you can do it in x's or y's. So if you're in x's, you just want to make sure your limits of integration are x values. And if you're in terms of y, you want to make sure your limits of integration are y values. So to do this, all you do is the square root of 1 plus the derivative squared. That's all it is. You're integrating the square root of 1 plus the derivative squared. And it just depends on which form you like, whether you like to call it f prime of x or whether you like to write dy dx. I've seen it both ways, and we see it both ways on problems on in the book and so forth. So you just got to make sure you recognize that we're doing the square root of 1 plus the derivative squared. So same thing down here. This is 1 plus the derivative squared. That's all you're doing, integrating. You just have to remember whether you're in x's or y's. So it's just a straightforward formula. That's all it is. So finding the length of the arc of a curve, right? All right, so to find this arc length, I'm just going to use the formula, okay? So I'm just going to integrate. Let's see, this says find the arc length of the function y equals 2x minus 5 between these points 1, negative 3, and 4, 3. So I'm going to go from 1 to 4. So my arc length is from 1 to 4. And I'm doing the square root of 1 plus my derivative squared. That's all I got to do. So we'll go over here to the function. This is y. So what is y prime, the derivative? The derivative is going to be 2. So then y prime squared is going to be 4. So my derivative squared is just 4. Whoops. I'm getting ahead of myself, so I'll just leave that at 2 then. So that means I'm doing integrating from 1 to 4, the square root of 1 plus my derivative squared, which is 4 dx, which means we are doing nothing but integrating from 1 to 4, the square root of 5. And that's a really simple antiderivative. All right, the antiderivative of square root of 5 when you're in terms of x's is radical 5x, is all it is. And then you're evaluating from 1 to 4. So now we're going to do the fundamental theorem of calculus. Or we'll put a 4 in here, so that would be 4 square root of 5 minus putting a 1 in here, 1 radical 5. So when you subtract 4 radical 5 minus 1 radical 5, the answer is 3 square root of 5. So all I did was I integrated from 1 to 4, the square root of 1 plus my derivative squared. That's all I did, and integrated that and did the fundamental theorem. All right, now what did we really do? Because I gave you a really simple, this is a line. 2x minus 5 is just a straight line. These 2 points are on that line. So all we did was find the distance of a segment of a straight line. So let's graph these 2 points and just see what we did here. All right, we've got 1, negative 3. So 1, negative 3. So here's 1, negative 3. And then we've got 4, 3. So go over 4, up 3, 4, 3. So we just found the length of this segment right here using calculus. Well, let's just do the same thing. Just verify the answer, doing good old-fashioned geometry. And let's just make a right triangle and do the Pythagorean theorem. So how tall is this here? Well, we're going from negative 3 up to positive 3, so that's 6. And then here, this distance here, we're going from 1 over to 4, so that distance is 3. So if I was just going to do good old-fashioned Pythagorean theorem to find this length c out here, I would do 3 squared plus 6 squared equals c squared. So 9 plus 36 equals c squared. That's 45. And when I take the square root on both sides, The square root of 45, that's 9 times 5, so that would be 3 square root of 5, and that's the same exact answer that I just got using the integral and the calculus. All right, but not all of our functions, of course, are going to be straight lines that we could just do straight up Pythagorean theorem. So I just wanted to show you and verify that the formula actually does work. All right, so we just found the curve, the length of the curve, even though it was a straight line, using this arc length formula here. So that's really all we got to do for each one of these. Now, sometimes they get a little strange as far as how to integrate and stuff. So let's just do a few more examples so that we're totally not just blown out of the water when I give you one that's kind of a little bit strange. All right, don't worry about this weird word. It's just describing the parabola, no big deal. So find the arc length of the semi-cubical parabola y squared equals x cubed between the points 1, 1 and the point 4, 8. Okay, so we're going to do the exact same thing. To find the arc length, all I'm going to do is I'm going to integrate, and we're going to be going from 1 to 4 because I'm doing from 1 to 4. I'm integrating from 1 to 4 the square root of 1 plus my derivative squared. All right, so up here's my function. Okay, well, if I take a look at that function and solve for y, so just doing a little scratch work over here, y squared is x cubed, so that means y is x to the 3 halves because it's the square root of x cubed, which is x to the 3 halves. So if y squared is x cubed, then when I take the square root of both of these, it'd be the square root of x cubed. So y is going to be x to the 3 halves. So then I just want to do what y prime is because that's what needs to go in my formula right here that I'm going to square. So what is the derivative of x to the 3 halves? That's 3 halves. X to the, when you subtract 1, would be 1 half. So I'm going from 1 to 4. 1 plus, when I square all this, I'm going to get 9/4. And then 9/4. And then if I square this, when you raise a power to a power, you multiply. So we're going to do 1/2 times 2. So that would be x to the 1st. All right, so there's my problem that I've got to do. All right, so what we got to do is integrate this problem here. So you might be able to do this one in your head, but let's do a little scratch work just to be certain. I'm going to let u squared, I'm going to do a u substitution, and I'm going to let u squared be 1 plus 9/4 x. So that means 2u du is going to equal 9/4 dx. All I did was take the derivative, right? That's all I did. The derivative of u squared is 2u du, and the derivative of 1 plus 9/4 x is 9/4, and then the dx. So remember, you solve for dx. So when I solve for dx, I'm going to multiply by 4/9, so that'll give me 8/9 u du. So now when I think about simplifying this out, it's going to be the square root of u squared, because what I did was I made this guy the u. All right, so it's going to be the square root of u squared, because that was my u squared. And then in place of dx, I've got 8/9 u du. So the square root of u squared is u. So then this becomes 8/9 u times u du. Okay? Because the square root of u squared is u, I times by u, that gives me u squared. So I'm doing the antiderivative of 8/9 u squared. Well, we've got that in the shade. We have got that, no big deal. All right, we got that. The antiderivative of 8/9 u squared is going to be 8/9 u to the 3rd divided by 3. So now when I put it all back in there, I got 8/9, or oh, I could actually say 8/27 if I wanted to, right? 8/27, and then u cubed. Remember, my u was the u squared was my 1 plus 9/4 x. So I want that quantity for u. So u is actually the square root of 1 plus 9/4 x. So what I have here is I have the square root of 1 plus 9/4 x raised to the 3rd power, which means it's really raised to the 3 halves if you wanted to say that. All right, so what are we doing? We're integrating from 1 to 4, which I don't need that anymore because I just did my antiderivative. So my antiderivative is 8/27, And then I can rewrite this as 1 plus 9/4, 1 plus 9/4 x to the 3/2. And I'm evaluating that from 1 to 4. So now I'm going to do the fundamental theorem of calculus. So I'm going to have 8 over 27. And this is going to be putting a 4 in here. So 4 times 9/4 is 9. So then 9 plus 1 is 10. So this will be 10 to the 3/2 minus putting a 1 in here. So that'll be 8 over 27. Putting a 1 over here will be 1 times 9/4, which is 9/4, plus 1 will be 13/4 to the 3/2. Now, I did not simplify that. If you want to get a calculator out and do the calculations, I left my answer like this. I didn't even plug it in the calculator. So I had 8 over 27, 10 to the 3/2, minus 8 over 27, 13/4 to the 3/2. And I just didn't go into all the calculations of that. That is the correct answer. You can do a decimal approximation if you would like. So what did I do? Just to recap here. I used the formula that we are integrating from 1 to 4, the square root of 1 plus my derivative squared. And once I simplified that, I did have to do a u substitution, and I made u squared the stuff under the radical just to make the u substitution a little easier. And then I found my antiderivative from that. And then I was able to evaluate my answer. All right, so that's what we did. Number 3. See, I've only got 5 of them. So number 3, set up an integral for the arc length of this hyperbola between the points 1, 1 and 2, comma, a half. And then I actually said, let's use a calculator because we don't want to integrate. We probably don't know how to integrate it, is probably why. All right, so let's set this up and then let's actually do the calculator. All right, so we're going to do the arc length. We know the arc length is the integral from 1 to 2 of the square root of 1 plus our derivative squared. All right, so what is our derivative? So let's see. This is our function, xy equals 1. So what I'm going to do is I'm going to solve for y. That'll be 1 over x. Okay, so now what is the derivative of this? Well, this is actually x to the negative 1. So y prime is going to be negative 1, x to the negative 2, right? You move your exponent to the front, drop a degree. So that's really negative 1 over x squared when I put him back where he belongs. And so that's what goes in here, negative 1 over x squared. So that's my derivative. All right, so now I just need to finish my math out here. So this is going to be 1 plus my derivative squared. So my derivative squared is going to be 1 over x to the 4th dx. So I'm integrating from 1 to 2, the square root of 1 plus 1 over x to the 4th dx. So then you have to math 9 that. So plug that in, math 9, and you should get 1.132 for your answer, because we don't know how to integrate 1 plus 1 over x to the 4th. All right. So that's just setting up, knowing that you're setting up the integral by doing the square root of 1 plus your derivative squared. I mean, I can't make this any easier. The only catch is when we get into further down the road when we revisit this again. Right now, we're just learning how to use the formula and get the arc length. Okay, so we are going to revisit this at a later date when it's going to be just a tad bit more challenging. All right, number 4 says, Number 4 says find the arc length of the curve y equals blah, blah, blah between the points 1, 1 and x comma f of x. Now notice my second point is not numbers. My second point is x comma f of x. So that means, just to let you know here, that your answer is going to be a function of x, because I didn't give you a stopping point for the function. So this basically is going to give you a function that when you pick a stopping point, you just plug that number in and you can do multiple stopping points and find multiple lengths. All right, but let's do the process exactly like we were thinking before. So arc length is going to be the integral from 1 to x. Okay, And then it's going to be the square root of 1 plus our derivative squared. And that's going to be the tricky part, the derivative squared. All right, now to get our derivative, y is this, so y prime is going to be 2x and then minus 1 over 8 times the derivative of ln of x, which we know is 1 over x. So there's our derivative. So the derivative x squared is 2x. The derivative of 1/8 ln of x will be a 1/8 times 1 over x, which gives me 1 over 8x. So there's my derivative. So that's going to go in here, 2x minus 1 over 8x. Okay, we got to square that. Lucky us. All right, now I really don't like having x's with an x up here. So here's what I'm going to do. I am going to trade out, because I don't like, because it can get confusing. I'm going to trade out these x's and put t's, because it's very confusing to have an x up here as one of your limits of integration if your function over here has x's too. So I don't want to do that. So I'm just going to trade those out and make those t's. Okay, so I'm still integrating from 1 to x, but I need to multiply all this out and simplify and see what in the world I got going on. Okay, so I've got 1 plus, I need to square this out. So remember, when you square a binomial, you square your first term. So my first term squared is going to be 4t squared. You square your last term. So my last term is going to be a negative 1 over 64t squared. Okay, and then it's going to be positive because I'm squaring. And then to get your middle term, you multiply and you double it, right? That's what you do whenever you want to do a minus b quantity squared. It's a squared and then b squared, and then the middle is always the product of these two multiplied by 2. So you multiply these together and then double it. Okay, so that's the little short form of how to square a binomial. So that's what I'm doing. I'm squaring the first term, squaring the last term, and then to get the middle term, I multiply these together and then I double it. All right, so what do you get when you multiply these together? What do you get when you multiply 2t times negative 1 over 8t? What do you get when you multiply those together? Well, the t's are going to cancel. So you're going to end up with negative 1 over, well, negative 2, excuse me, negative 2 over 8, which is negative 1/4. And now you're going to double that. You're going to times that by 2. So when you times negative 1/4 by 2, you get negative 1/2. All right, so I get a negative half in the middle. Okay, now this is the beauty of this. It looks like it's getting complicated, but it's not. All right, so then now what have I got here? If I combine these terms right here, I have a 4t squared. And then I also have 1 minus a half, which is a positive a half. And then I've got positive 1 over 64t squared dt. All right, so all I've done there is combine now that middle term that I got where the t's canceled out and it ended up just being negative a half. I've combined that with the 1 now, so that leaves me with a positive a half. Now, I want you to notice something. When we multiplied out this factor right here, we got this answer. I squared the first term, squared the last term, multiplied and doubled to get the middle. And that gave me this. So now compare what this is to what we have in here. The only difference is I now have a plus right here. So that tells me that this is now a perfect square, same as this, but with a plus. That's the beauty of these problems, okay? They always work out quite nicely. All right, so we're integrating from 1 to x. So this is a perfect square under here. This is a perfect square, and it's the same thing as this right here, 2t, but with a plus sign, 1 over 8t quantity squared dt. So now I can take the square root of this quantity that's a perfect square, the square root of a perfect square, that just cancels, and I'm left with 2t plus 1 over 8t. That's all I'm left with. All right, so I'm left with that. All right, now we're ready to do our antiderivative. So what is the antiderivative of 2t? Well, that's t squared. Now, what's the antiderivative plus? What's the antiderivative of 1 over 8t? Well, you keep your 1 over 8, keep your coefficient. What's the antiderivative of 1 over t? Well, that's natural log of t. I don't need the plus c because I'm evaluating from 1 to x. So now we're going to do the fundamental theorem of calculus. So I'm going to put an x in, so that'll be x squared plus 1 over 8 ln of x in absolute value bars. And then, which x should be a positive number anyway. And then subtracting, putting 1 in there. So 1 squared is going to be 1 plus 1 over 8 natural log of 1, which we know the natural log of 1 is 0, so that goes away. So my final answer here is x squared plus 1 over 8 ln of x. X should be a positive number, I believe. Let me go back up here and look. On the curve from 1, 1 to x f of x, it should be. Okay, and then let's see, so I got x squared plus 1 ln of x minus 1. And that's my answer. And they told me that my answer would be a function because I was integrating from 1 to x. So my answer is going to be a function of x. So that means if I do the length from, so it said we were going from 1, 1. So then if I wanted to go from 1, 1 to say 3 something, now all I got to do is plug a 3 in this answer down here and I got the length. If I want to find the length from 1, 1 to say 6 something, 6 comma whatever, then now all I got to do is put a 6 in this answer and I've got the length of that. So this is like an accumulative function where now you can pick whatever your second point's going to be, and this is like a little equation that tells you the length of that curve to that point if you start with 1, 1. All right, you have to start with 1, 1 as your first point. It has to start with this. And then whatever second point you're going to. So again, what did I do? I did the arc length is the square root of 1 plus the derivative squared. When we did our derivative, squared it, and then combined it with the 1, we ended up with the same binomial squared just with a plus sign instead of a minus sign, which now meant I could take the square root of something squared by just canceling these dudes, and I was left with 2t plus 1 over 8t, whose antiderivative is really sweet. And then I did the fundamental theorem. All right, so not too terribly bad. It's just using this formula. All right, last problem. Let's just do one that's not weird. That's just straightforward. Find the arc length of the function y equals natural log of cosine on the interval from 0 to pi over 4. So we know to do our arc length, we're going to integrate from 0 to pi over 4 because that's the length they want. We're going to do the square root of 1 plus our derivative squared. So we just need to figure out what is the derivative of this function over here. What is y prime? Well, how do you take the derivative of natural log? Well, derivative of natural log, if you remember from last year, derivative of natural log is the derivative of the function, so that would be negative sign, over the function, right? Derivative of your function, derivative of cosine is negative sign, divided by the function, so divided by cosine. So that tells me we got negative sine over cosine, which is the same as negative tangent. Because remember, tangent is sine over cosine. So I'm going to put a negative tangent in here. All right, so all I did was took the derivative and put it in there. Okay, so now we got to work our magic on this. So I'm doing integrating from 0 to pi over 4. I now have 1 plus, when I square this, I get tangent squared. Now we've got to do our wonderful trig stuff. There is an identity for 1 plus tangent squared. 1 plus tangent squared is secant squared. So now I can do the square root of secant squared. The square root of secant squared is just secant. And now we've got to do the antiderivative of secant. So that's one of the ones that we had to memorize in our book there, that the antiderivative of secant is natural log of secant plus tangent. Natural log of secant plus tangent. And all I got to do is evaluate that now from 0 to pi over 4. So now I'm going to do the fundamental theorem of calculus. So I'm going to put a pi over 4 in here first. So I'm going to do natural log of the secant of pi over 4 plus the tangent of pi over 4 minus, putting a 0 in there, the natural log of secant 0 plus tangent 0. All right, so now we just got to do some simplifying of those secants and tangents. All right, so we got to think, what is the secant of pi over 4? So where are you on the unit circle? If you're at pi over 4, you're here in the middle of the first quadrant. You're at radical 2 over 2, comma, radical 2 over 2. All right, so my secant, remember, is the reciprocal of cosine. So the reciprocal of our cosine here is just going to be 2 divided by radical 2, which is radical 2. Plus, now what's the tangent of pi over 4? Now tangent of pi over 4 is sine over cosine. So if you do the y coordinate divided by the x coordinate, that's going to be 1. All right, now we're going to do the same thing over here for 0. So if you're at 0 on the unit circle, you're at the point 1, 0. Okay, right? Secant is 0, tangent is 0. So we're at 0 on the unit circle, which is the ordered pair 1, 0. So what is the secant? The secant is the reciprocal of cosine. So the reciprocal of cosine, the reciprocal of 1 is going to be 1 plus, now what's the tangent of 0? Tangent is the sine divided by the cosine. So that would be 0 divided by 1, so that's 0. So this is giving me the natural log of the square root of 2 plus 1, which I don't need bars because that's all positive, minus the natural log of 1 plus 0, which is 1. We know the natural log of 1, that equals 0. So my final answer is just the natural log of the square root of 2 plus 1. That's my answer. The natural log of the square root of 2 plus 1. And if you wanted to punch it in a calculator and get an actual decimal answer, you could, but you don't have to. You don't ever have to simplify those. So all I did was I used the formula. I did the square root of 1 plus the derivative squared. It's just a matter of doing the algebra after that and then integrating and then doing the fundamental theorem of calculus. And if it's trig, thinking about your unit circle and getting your answers. All right, so the formula in itself is not hard. Okay. All right, so your assignment is to do some practice problems on page 543, which I want you to do number 1, and which I think is just a linear one, and then numbers 3 through 15 odd, and just practice doing the arc length formula.